Hi everyone, ISC and ICSE syllabus has been further reduced for the examination 2021, and in this video I am going to discuss that reduced syllabus for computer science for class 12th. Alright, for ISC. Okay, but before that I want you all to subscribe my channel and don't forget to press the subscribe button. 2021. Now, how to reach to that further reduced syllabus? You type CISE in the Google, and then you are getting this site here, and you can click upon that, and you have in front of you this home page of CISE.org, and here you have this option publication. So just click upon that publication and it will take you to this page, and where it's written further reduced syllabus for ICSE class 10th and ISC, that is class 12th, for the year 2021 examinations. Alright, now students, here I'm going to discuss the ISC syllabus. So I just click ISC here, and all the subjects in which syllabus has been further reduced are listed here. Okay, so you can just click any of the subject or subject of your choice. For the subject you want to see the reduced syllabus, you can just click upon that and you will find that. Okay, so in this video I'm going to discuss the computer science syllabus for ISC or class 12th. So I'm going to click that. Alright, and just see what is there. So either if you want to download, you can download that, click that, it will be there in front of you. Now here you find computer science reduced syllabus or further reduced syllabus. So here you see that there will be two papers in the subject, that is theory 3 hours 70 marks, paper 2 practical 3 hours, that is of 30 marks. Okay, now students, we move ahead with the syllabus of theory now. Paper 1 theory 70 marks, paper 1 shall be of 3 hours duration and be divided into two parts. Part 1, that is of 20 marks. This part will consist of compulsory short answers, questions, testing knowledge, application and skills relating to the entire syllabus. Alright, now what is there in the part 2? Part 2 50 marks. This part will be divided into 3 sections, A, B and C. Candidates will be required to answer 2 questions out of 3 from section A, each carrying 10 marks, and 2 questions out of 3 from section B, each carrying 10 marks. And then 2 questions out of 3 from section C, but here what is there? Each carrying 5 marks. Alright, therefore a total of 6 questions are to be answered in part 2. Alright, now students, we go for the syllabus now, which is the reduced one. Section A, just look here, Boolean algebra, propositional logic, well-defined formula, that is WFF, truth values and interpretation of well-formed formula, or WFF, truth tables, satisfiable, unsatisfiable and valid formula, equivalence laws and their use in simplifying WFFs. Students, after that, propositional variables, the common logical connectives. Okay, that is negation. Then we have second one, that is conjunction, then disjunction, right, then implication, then here it is biconditional, so conditional and biconditional both, then definition of WFF, a representation of simple word problems as WFF. This can be used for motivation, the values true and false, interpretation of a WFF, truth tables, satisfiable, unsatisfiable and valid formula. Equivalence laws, then when they talk about, so we have here commutativity of conjunction, disjunction, associativity of conjunction, disjunction, alright, distributivity, and after that we have De Morgan's laws, then law of implications, P conditional Q, then not P, disjunction Q, or you may say not P or Q. Then students, we have law of biconditional, P biconditional Q. Alright, here we have P conditional Q and Q conditional P because they are equivalent. Then identity, after identity, law of negation, law of excluded middle, then law of contradiction, then tautology and contingency, simplification, rules for conjunction and disjunction or and or, then converse, inverse, and contrapositive. Alright. After that, students, binary valued quantities, basic postulates of Boolean algebra, operations and or not, truth tables. Then there is basic theorems of Boolean algebra. In this, duality, idempotence, commutativity, associativity, distributivity, operations with 0 and 1, complements, absorption, involution, De Morgan's theorem and its application, reducing Boolean expression to sum of products and products of sums forms, Karnaugh maps up to 4 variables, verify the laws of Boolean algebra using truth tables, inputs, outputs for circuits like half and full adders, majority circuits, etc., SOP and POS representation, max term, min term, canonical and cardinal representation, a reduction using K-map and Boolean algebra. Alright students, so that was there. After that, in the hardware, elementary logic gates, not and or, NAND, NOR, XOR, XNOR, and their use in the circuits. After that, students, applications of Boolean algebra and logic gates to half adders, full adders, encoder, decoder, multiplexer, NAND, NOR as universal gates. After that, show the correspondence between Boolean method and the corresponding switching circuits or gates. Show the NAND and NOR gates are universal by converting some circuits in purely either into NAND or NOR gates. Alright students, after this we have here section B, the programming part, where we have section B. The programming element is in the syllabus of section B and C is aimed at algorithms, algorithmic problem solving, and not merely learning of Java syntax. Alright, the Java versions used should be 5.0 or later. For programming, the students can use any text editor and the Java C and Java programs or any other development environment, for example BlueJ, Eclipse, NetBeans, etc. BlueJ is strongly recommended for its simplicity, ease of use, and because it is very well suited for an object first approach. Alright, now let's talk about the topics here. Implementation of algorithm to solve problems. The students are required to do lab assignments in the computer lab concurrently with the lectures. Programming assignment should be done such that Each major topic is covered in at least one assignment. Assignment problems should be designed so they are sufficiently challenging. Students must do algorithm design, address correctness issues, implement and execute the algorithm in Java, and debug where necessary. Alright, after that, programming in Java, that is the review of 11th section B and C, that is meant for, where note that item 4 to 13 should be introduced almost simultaneously along with classes and their definitions. While reviewing, ensure that new higher order problems are solved using these constructs. Now objects are there. Objects as data or behavior, that is attributes and methods. Object as instance of a class. Constructors. Alright. Analyze of some real world programming examples in terms of object and classes. Basic input output using a scanner from JDK. Input output exception. Tokens in an input stream. Concept of white space. Extracting tokens from an input stream, string tokenizer class. Alright. After that, student, primitive values, wrapper classes, types, and casting, means typecasting. Primitive values and types: byte, int, short, long, float, double, boolean, char. Corresponding wrapper classes for each primitive type. Class as a type of the object. Class is a mechanism for user defined types. Then changing types through user defined casting and automatic type recursion in some primitive types. Alright. Now after that, students, we have here variables to name for values, named constants, that is final, expressions, arithmetic and logical, and their evaluation, operators, associativity, precedence, assignment operations, then difference between the left hand and the left hand side and the right hand side of the assignment, then a statement scope, statement conditional, if else, if switch case, ternary operator, looping, for while, do while, continue, break, growing statements in blocks, scope and visibility of variables, then method as an abstraction for complex user operations on objects, formal arguments and actual arguments in methods, static method variables, the this operator, example of algorithmic problem solving using methods, number problems, finding roots of algebraic equations, etc. Arrays, string, then structure, data type, arrays, single and multi-dimensional, address, calculations, strings, example, algorithm that we structure, data type, searching, finding, maximum, minimum, sorting techniques, solving systems of linear equations, then substring, concatenation, length, access to char in the string, etc. Alright. After that, students, we have here storing many data elements. Wait a minute, students. We have here storing many data elements of the same type requiring structured data types like array. Access in arrays is constant is a constant time and does not depend on the number of elements. Address calculations, row major, column major, sorting techniques, bubble, selection and insertion. All the three techniques are there. The structured data types can be defined by classes. String, introduce the Java library string class and the basic operation on string, accessing individual characters, various substring operations, concatenation, replacement, index of operations. Right, students? After that, there is recursion, concept of recursion, simple recursive methods, factorial GCD, binary search, conversion of representation of number between different bases, means hexadecimal to binary and vice versa, and the other numbers also. All right. Many problems can be solved very elegantly by observing that the solution can be composed of solutions to smaller versions of the same problem. Alright, divide and conquer is the basic idea of the recursion. So here, smaller versions of the same problem with a base version having a known simple solution. Recursion can be initially motivated by using recursive equations to define certain methods. These definitions are fairly obvious and are easy to understand. The definitions can be directly converted to a program. Emphasize that any recursion must be a base case, otherwise the computation can go into infinite loop. The Tower of Hanoi is a very good example of how recursion gives a very simple and elegant solution, whereas non-recursive solutions are quite complex. Okay, now we talk about this section C, inheritance, interface, polymorphism, data structure. So inheritance, interfaces and polymorphism. Inheritance, super and derived class, member access in the derived classes, redefinition of variables and methods and subclasses, abstract classes, class object, protected. After that we have protected visibility. As we all know that protected is very critical or important to the inheritance. And then subclass polymorphism, alright, and dynamic binding. Okay, emphasize inheritance as a mechanism to reuse a class by extending it. Inheritance should not normally be used just as to reuse some methods defined in a class, but only when there is a genuine specialization or subclass relationship between objects of the superclass and that of the derived class. Okay. Then we have interfaces in Java, that is conceptual. So no programming for interface student. Alright, a small example of interface can be included, right? Otherwise interface is conceptual here. Now emphasize the difference between the Java language construct interface and the word interface, often used to describe the set of method prototypes of a class. After that, students, we have data structure. Basic data structure, stack, queue, implementation directly through classes, conversion of infix to prefix and postfix notations, basic algorithms and programs using above data structures, then binary tree traversal, conceptual. Alright, so students, you can see that there is no linked list over there. Alright, so stack queue is there, implementation through classes, conversion of infix to prefix and postfix, but there is no linked list. Alright, now binary trees, tree traversal, only conceptual. Alright, no programming or coding is required for this. The following should be covered. Binary tree, apart from definition, the following concept should be covered. What is root, internal nodes, external nodes, leaves, then height, then depth of the tree and node, then level, size, degree, siblings, and tree, complements, balancing, traversals, pre, post, and in order. Alright. After that, students, they talk about the practical. In the practical, they have 30 marks practical. The paper of 3 hours duration will be evaluated by the visiting examiner appointed locally and approved by the council. And then it will have planning session and the examination session. Alright, students, so here you can find the details of that. The total time to be spent on the planning session and the examination session is of 3 hours. Maximum of 90 minutes permitted for the planning session and 90 minutes for the examination session. Candidates are to be permitted to proceed to examination session only after the 90 minutes of the planning session are over. The candidates will be required to prepare an algorithm and a handwritten Java program to solve the problem. Right after that examination session, the program handed in at the end of the planning session shall be returned to the candidates. Means after the program is done, and then when the person comes to the lab, right, so the copy will be given to the student. All right. The candidate will be required to key in and execute the Java programs. So whatever is in the copy, the student has to write on the system in the lab. All right. And show execution to the visiting examiner. Printout of the program listing including output results should be attached to the answer script containing the algorithm and handwritten programs. This should be returned to the examiner. The program should be sufficiently documented so that the algorithm representation and development process is clear from reading the program. Large differences between the planned program and the printout will result in the loss of marks. Teachers should maintain a record of all assignments done as a part of the practical. That's a very important point for the teachers through the year, and give it due credit at the time of the cumulative evaluation at the end of the year. Students are expected to do a minimum of 20 assignments for the year. All right. Now here you see marks out of 30 should be distributed in as given below. Then continuous evaluation. Candidates will be required to submit a work file containing the practical work related to programming assignments done during the year. So here programming assignments done throughout the year, internal evaluation, that is of 10 marks. Programming assignments done throughout the year, that is of 5 marks. Then terminal evaluation, solution to programming problem on the computer, 15 marks. Mark should be given for choice of algorithm and implementation strategy, documentation, correct output on known inputs mentioned in the question paper, correct output for unknown inputs available only to the examiner. After that, note algorithm should be expressed clearly using any standard scheme such as pseudocode. Right. Equipments, there should be enough computers to provide for a teaching schedule where at least 3/4 of the time available is used for programming. All right. So all these instructions you will find there, right? And all these facilities which are required. So that is also specified. So students and teachers, you can see all these things from this site's homepage, and go to publication and find it out. And students, please subscribe the channel for any further updates, and don't forget to press the bell icon as well.